Hello everyone. My name is Hassan Bitar and my partners Ala Arabiyat and Yazan Jabir. We are a student of Princess Sumaya University for Technology and we are here to provide a video that related to microwave using Kitabi program and MATLAB calculator to calculate available power gain, noise figure and vswr. The main reason from this video is to save a lot of effort and time to get this calculation using these programs. And we want to thank our university and Professor Abdullah Zabi, who helped and motivated us to this work. And my partner will continue with you. And now we have this example 4.31. The scattering and noise parameters of a BGT measured at a bias point for low noise operation. And we have the values of S11, S12, S21, S22, F minimum and gamma output and Rn. And we should to design a microwave transistor amplifier to have a minimum noise figure. And we will use Kitab program to solve it. And now we will import the Smith chart. And we will open the MATLAB calculator and put the values of S11, S12, S21, S22. Then design. Then we will click on available power gain. And here we will put 14.7 and we have the radius, magnitude and the phase. Now we will choose 13.7 and the radius 0.14, magnitude 0.85. Now we will back to the Kitab studio and we will determine the phase of it and draw the line from the center to the phase we choose. And it is equal minus 1.5. And it is here. Now we will use the ruler and draw the line and now we will back to the calculator and the radius equals 0.14. Now we will determine the reflection coefficient from here and it is equal 8.2. Now we will go to the calculator and 8.2 multiplied by the magnitude and it is equal 0.85 and it is equal 6.9 and the radius 0.14 and it is equal 1.148. Now we use the caliper to determine the center and it is equal 6.9 and we should edit it from And now from the center we will draw the radius, and it is equal 1.148. And now we will put on it 13.7 dB, and that's the first circle. Now we will back to the calculator and choose the value 20.7, and that's the radius and the magnitude, and the same way we will multiply it by 8.2. Then we will determine the center of it, and it is equal 6.2. And now we will plot the circle and the radius 1.19. Then we will back to the calculator and put and we have the radius and the magnitude. Then and the center is 5.4. Then from the center we will draw the radius, and it is equal 2.7. 2.7. Then again we will back to the calculator and put 10.7, and we have the values. And the radius equal 4.7. Then from the center we will draw the circle, and the radius equal 3.5. And now we will back to the calculator and put 10.7 and now 9.7 dB. And the center we have is 4. And the radius is 4.2. 4.2. Then we will back to the Smith chart and draw the circle. And the radius is 3.4. And the radius equal 4.8. And now we will back to the calculator and 7.7 dB. And the radius and magnitude we have the center equal 3.3, and the radius equal 5.3. And now we will back to the calculator and put 6.7, and the radius equals 0.71, and the magnitude equals 0.289. Then we will plot it, and the center equal 4.2, 2.4, I mean. Then from the center we will draw the radius 5.8, and now we finish the available power gain. And now we will back to the question, and we will draw the noise figure circles. We will back to the calculator and press on noise figure circles. From the question we have the values of Rn and Fmn and all values, and the gamma equals 0.475, and phase equal 1, and F minimum equal 2.5, and Rn equal 3.5, and Fi we will press on 2.5, and the noise figure parameter equals 0 and radius equals 0, so we will take 2.6 dB, and here we have the radius and magnitude and the phase, and we will back to the kitab to determine the phase and draw the line from the center to the phase, and we will use the ruler to make it. And we will draw the line, and we will take the magnitude 0.45 and multiply it by 8.2, and the center equals 3.731. And now we will draw it, and the center equal 3 point, and that's the center. and 3.7 we have 3.3.7 then from 3.7 we will draw the radius and it is equal 1.5 and the next value we will go to the calculator and got down 0.475 and 2.5 and here 2.3.5 and now we will choose 2.7 and the center we have is equal 0.435 and the radius 0.23125 and then the same way we will the radius equal 3.6 and the center equal 2.1 and now we will choose 2.8 dB 2.8 dB and now we will draw 2.8 and the radius equal and the center equal 3.4 3.4 and it is here and from the center we will draw the circle and the radius equal 2.1 Mm. Mhm. And now we will, okay, and we will check for 2.7, and the radius are equal 3.6, and the radius equal 2.1. Mhm. And 3.8, 2.8, and now we will use 2.8, and the radius and magnitude are here, and we will continue on the Kitab Studio, and from the tools we will plot and determine the center and the radius, and the radius equals 3.4, and the radius equal 2.55. And now we will go to the calculator, and 2.9, the radius and the magnitude are equal 0.4, 0.357. From the center we will draw the radius, and it is equal 2.9. And now we will choose the 3 Fi, and the center is equal 3.14, and from the center we will draw the radius, and it is equal 3.2. And now we finish the noise figure circles.
And now we will specify the vs omega r, and we will take this point and move to find the point, and from the center. And after all of that, the answer for matching network ZA and ZB and ZB equal that, and that's series capacitor and that's parallel capacitor, and ZA are here, ZA and ZB are here, and the YP are here. And thank you for watching this video.
And now, for constant VSWR calculations, we enter here the gamma node and the phases. So VSWR is equal 4.26 and it's valid. Thank you for watching the video.